The $20 billion admission. NVIDIA just spent $20 billion to admit the GPU has hit a memory wall. By licensing Groq's core architecture and hiring its founding team, Jensen Huang is effectively ending the era where one chip does everything. This move targets the hidden bottleneck of the H100 and B200 cycle, where massive raw power was being choked by slow memory access during real-time reasoning. To keep its lead, NVIDIA had to buy the one technology that was making its flagship chips look slow. This is the start of a massive architectural pivot called the inference crash, the SRAM advantage over HBM. The technical reason for this acquisition is a fundamental mismatch in how data moves. Traditional GPUs rely on high bandwidth memory, which is excellent for training but creates a latency floor during the decode phase of a chatbot response. Groq's language processing units use on-chip SRAM that delivers 150 terabytes per second of bandwidth. That is nearly 7 times faster than the memory speed of the latest Rubin GPUs. By offloading the sequential task of token generation to these specialized LPUs, NVIDIA can finally offer the deterministic, sub-millisecond response times required for agentic AI to work at scale. This integration solves the physics problem of data movement, the antitrust loophole strategy. On Christmas Eve 2025, NVIDIA structured this as a non-exclusive licensing deal rather than a traditional merger to stay off the radar of global regulators. They technically bought the assets and hired the brains, including founder Jonathan Ross, while leaving a shell of Groq to operate independently. This maneuver allows NVIDIA to integrate LPU technology into its new Vera Rubin platform without triggering a multi-year antitrust investigation that would have stalled their 2026 roadmap. It is a strategic masterstroke that secures the technology while leaving the regulatory headache to the competition. The result is a hybrid rack that pairs LPU speed with GPU scale, scaling through the Samsung partnership. NVIDIA is using this deal to break the TSMC bottleneck. The new Groq 3 LPX racks are being manufactured by Samsung on a 4-nanometer process, diversifying NVIDIA's supply chain for the first time in years. This move is a direct response to the massive demand for tokens as a service, where efficiency is measured in tokens per watt rather than raw flops. By running the pre-fill phase on Blackwell GPUs and the decode phase on Groq LPUs, these systems are hitting 35 times higher throughput per megawatt. This dual-track manufacturing strategy ensures that NVIDIA can ship millions of inference-optimized units even if the main high-bandwidth memory market remains constrained. This shifts the battleground from capacity to efficiency. The real implication. NVIDIA's integration of Groq technology marks the definitive end of the general-purpose AI chip era and the beginning of the heterogeneous data center. By splitting the workload between training-heavy GPUs and inference-specialist LPUs, NVIDIA has successfully neutralized the architectural threat from startups like Cerebra's, which just went public into a market Huang already moved to consolidate. For operators and builders, this means the software stack is about to get more complex as we move from simple GPU clusters to multiprocessor AI factories that treat reasoning as a separate hardware problem. The strategy here isn't just about speed, it's about making sure that no matter how specialized the AI market becomes, the only viable platform remains NVIDIA-branded. Watch the shipping volume of the Groq 3 LPX racks in the third quarter of 2026 as the lead indicator for the next leg of the AI infrastructure boom. Subscribe for more.